Today we are going to continue our study of lesson 13.2 by doing the second half, part B, of what is heat. We just have one objective today that you should be able to know when we finish the lesson, and that is how to use specific heat capacity to calculate heat. You will come back and watch the study jam about heat when I'm finished teaching. All right, so we talked about conduction, convection, and radiation last time. Conduction, we said, was direct contact. Convection moves like in a circle, up and down. And then radiation is like the sun's rays, electromagnetic waves. So the Earth's atmosphere allows the sun's visible light to pass through it. But the atmosphere also traps energy in it as well. And this process is called the greenhouse effect. Without this very important thing called the greenhouse effect, Earth would be a cold, lifeless planet. In other words, life could not exist without the greenhouse effect here on Earth. So our atmosphere traps the sun's energy because of the greenhouse gases like water vapor, carbon dioxide, and methane, to name a few. However, there are some scientists out there that are concerned that high levels of these greenhouse gases in the atmosphere may trap too much energy and make the Earth too warm. So if you've ever heard of the global warming theory, that is what this is talking about. Now again, this is a theory. Not everyone believes this. It's not a law. But either way, the greenhouse effect allows this visible light from the sun, as I said earlier, to pass through the atmosphere, and it heats the Earth. And then Earth radiates the infrared waves, some of which escape back into space and some of which come back down to Earth. And the greenhouse gases that are in the atmosphere trap some of the re-radiated energy near Earth's surface. And that's what makes this planet inhabitable. So without that, no life. However, if too much is being trapped, as some people believe, then that could be bad as well. So let's deal with specific heat for just a second. The amount of energy needed to change the temperature of 1 kilogram of a substance by 1 degrees Celsius is specific heat. So the higher the specific heat something is, the more energy it's going to take to increase its temperature. Most metals have very lower specific heats. On the other hand, the specific heat of water is very high. So unlike temperature, energy transferred between objects cannot be measured directly. So with temperature, we use a thermometer. With this energy transfer, we're going to use this equation. This is how you calculate heat. Heat, which is measured in joules, Joules, equals the specific heat times the mass times the change in temperature. So you multiply these three numbers together to get your heat. When the temperature of an object increases, the value of heat is positive. When the temperature of an object decreases, the value of heat is negative. So you can think of this as a number line. And on that number line, you have 0 in the middle with your positive numbers going up, your negative numbers going down. So when the temperature increases, it's going up. So that would be your positive value. the temperature decreases, it's going down. That would be your negative value. All right, this is the end of lesson 13.2b. There's a funny video about specific heat on the next slide that you're going to watch today to conclude this lesson. And then tomorrow, you'll watch the Bill Nye video on phases of matter, which is the slide after the funny video. So don't go ahead and watch Bill Nye today. You're going to do that later. So this is the video that you'll watch today. And this is the Bill Nye that you'll watch later. And the next time we will pick up with lesson 3, which will be on matter and heat.